All right, so now that we have finished graphing exponential functions, we're going to go ahead and graph logarithmic functions. And logarithmic functions are the inverses of exponential, and so all the important information we looked at last time is just flipped. So instead of the point 0, 1, you have the point 1, 0 for the parent graph. Instead of having the point 1b, you have the point b1 for the parent graph, and instead of having a horizontal asymptote at y equals 0, we have a vertical asymptote of x equals 0. So if our parent function, let's say maybe it had a base of 2, log base 2 of x, that would have a vertical asymptote at 0, and then we would have the point 1, 0, and 2, 1. And then the graph, like normal, it would follow the asymptote. And then instead of growing very quickly up, it grows very quickly to the side. All right, so let's go ahead and look at these example problems and find all the different things that we're used to finding. So first, we're going to go ahead and recognize the base so that we don't get it confused with one of the transformations. So this log has a base of 2. And then aside from the base, it has been reflected over the x-axis. And I can tell that because of the negative in the very front. It has been shifted to the left 1 and up 5. And I can find the asymptote by looking inside the function this time. So horizontal asymptote we find by looking at the outside. Vertical asymptote we find by looking at the inside. And just like normal, when we look at the inside, we always do the opposite. So the vertical asymptote is x equals -1. All right, so I'm going to go ahead and graph this on my calculator. Now, I think most of you guys have the newer calculators, which means to be able to type in a log, you can actually go straight to that and do a log base 2. So before that, we're going to go ahead and type our negative, so get your negative in there, and then you're going to hit the math button and go up, up. So math up, up, log base 2 of x plus 1 with a plus 5 on the end. So that's what it looks like. My window's normal. All right, and so for us to graph this, we're going to kind of do the same thing we did before where we're going to look at this. So -1 is where the asymptote is. So we're going to look just to the right of that at 0. We've got 0, 5, and we've got 1, 4. And so we have to draw the points getting closer to the asymptote and then growing very quickly out to the side. All right, so for these graphs, the domain is going to start at the asymptote and then go right forever. So the furthest left that this graph goes is -1. The furthest right that it goes is to infinity. For the range, the lowest that this graph goes is -infinity because it goes down forever. The highest that it goes is +infinity. We can go ahead and do increasing and decreasing. So I'll grab my little stick figure guy. And he is decreasing, kind of walking down into a valley. So this x value right here is -1. So it's an arrow that's to the left, but it gets stopped by that asymptote. So the x value is -1. The x value on the right side is a right arrow, and so that's an infinity. So we're going to say that this graph is decreasing from -1 to infinity, and it is not going to increase ever. All right. As far as max and min, we're going to say none. No mountaintop, no valley. We can find X and Y intercepts. So on this one, you can see if I look at this that the graph is getting closer to the x-axis, but on my screen it hasn't crossed it yet. So that means I need my window to be bigger. And I need the X max to be bigger. So I'm going to change that to 20 and see if that fixes it. Not quite. I'll try 30. It looks like we're almost there. Maybe I'll try 50 this time. Okay, so we definitely did cross. So second trace number 2, I'm going to do my left bound and right bound. And I can tell that it hopped over. If you guys watch the y values, you could see they went negative, so I mean it hopped over the x-axis. So 31. So our x-intercept is 31, 0. The y-intercept is 5. Is the graph continuous? Yes. We also want to look at end behavior. So as x goes to the left forever, as x goes to the right forever. So as I look to the left, my graph just stops. It does not go to the left forever. And so for y, I'm going to say y, well, you don't have to say goes to, you can say equal. Y is undefined. So y doesn't go to negative 100, or x doesn't go to negative 100, x doesn't go to negative 500, it stops at negative 1, so it doesn't go very far, and so y is undefined. When you look to the right forever, the y value is going down. It's doing it slowly, but it's still going down, so that's going to be negative infinity. All right, let's go ahead and look at the next one. So this one has a base of 4. The transformations are vertical stretch of 2, right 3, and up 4. And when I look at this one, I can see that my vertical asymptote is going to be at positive 3 this time. Okay, so I'll go ahead and graph it. So I'm going to hit the 2 first, and then I hit the math button and go up, up. Log base 4 of x minus 3 with a plus 4 on the end. I'm going to make my window normal again. There we go. Okay, so I'm going to look at the table, and I'm looking at x equals 3. There's my asymptote, nothing to the left of it, but there's my asymptote. So 4, 4, and 5, 5 are the points. And then I follow them toward the asymptote, and then make them grow very quickly on the side. Okay, so for the domain, the graph does not go left past 3. So 3 is the furthest to the left, infinity is the furthest to the right. The range goes down forever and up forever. If I put my stick figure over here, this left arrow is getting closer and closer and closer to an x value of 3, but it's not going to go any further left than that. My stick figure is increasing. He's walking up a big hill. And then I have a right arrow, and so that's a positive infinity. And so for the increasing and decreasing intervals, I can say that I'm increasing from 3 to infinity. And never decreasing. There is no max or min for this graph, no mountaintops, no valleys. X-intercepts and Y-intercepts, I can see that there's going to be no Y-intercept because the asymptote keeps the graph from crossing the y-axis. But there is going to be an X-intercept. It's going to be pretty close to the asymptote. So if you look at the graph makes it look like the graphing calculator makes it look like the curve stops, but it doesn't. It gets closer and closer to the asymptote, and your calculator just has a really hard time graphing lines when they get close to vertical, so it kind of cuts off. So we do know that it gets really close though, and I can look here and I can see that the x-intercept is going to be somewhere between the vertical asymptote at 3 and 4. Somewhere between 3 and 4, very, very close to 3. So I'm going to go ahead and do second trace number 2, And instead of scrolling, because this one is very hard to scroll left and right for because we can't even see it, instead of scrolling, I'm going to type 3 for my left bound, and I'm going to type 4 for my right bound. So somewhere between 3 and 4. And 3.0625. 3. Okay, so again, I did second trace number 2 like normal, but instead of scrolling, I just told my calculator to look somewhere between 3 for the left bound and 4 for the right bound. And I hit enter when it said guess. I just hit enter one more time and it found it for me just fine. All right, is this graph continuous? The answer is yes. You can trace it with your finger without picking up your finger, so we can get the whole thing. For the end behavior, as x goes left forever, we realize that it does not go left forever, it stops. So we're going to say undefined. As x goes to the right forever, the y value goes up.